Welcome to part 7 of this 12-part Python tutorial series for beginners. In this chapter, we're going to learn about dictionaries. Dictionaries are a data structure that stores key value pairs. It's similar to a list in that it lets us store a collection of data. Except instead of relying on the insertion order or an index to access individual items, we use something called a key. And here, a key is a unique identifier that we can use to access a value in the dictionary. It can be any arbitrary value, for example, a string like user ID. To get a better idea of why a dictionary is useful, let's compare it to a list. Lists are good at storing sequential data. The index starts at 0 and goes up by 1 for each item. And you can also use this index to access the item. But what if the order of the data doesn't matter to us? For example, imagine we wanted to store the prices of different products for our e-commerce business. And say I wanted to look up what the price of an apple was. How would I look that up in a list? I could go through each item and check if my product is there. So in this case, my Apple product is there at index 0. And then maybe I could use another list, like the fruit prices below, to look up the price at the same index. But then do you see the problem with that? There's actually two problems. If this list had 1 million products, I'm going to do a lot of extra work to look that up. I potentially have to go through every single item in the list before I can find the one I'm looking for. And if the indices between these two lists ever became out of sync, then I could be looking up the wrong data. For example, if I remove an item from the fruits name, but I forget to remove the same item from the prices, suddenly I could be looking up at the wrong prices because the index had shifted. So how exactly do dictionaries help us solve this problem? Well, for one thing, dictionaries allow us to look up things a lot faster than lists as long as we know exactly what it is that we want to look up. For example, if we know that we want to look up an apple and we can provide that as a string to the dictionary can look it up right away. And the time that it takes to look it up doesn't really change whether there's one item in the list or 1 million items in the list. So if you want to know how that works, you're going to have to learn about data and algorithms, but dictionaries can look up things really fast if you know what you want to look up. Secondly, it also lets you store pieces of data that are connected together a lot better than lists can. So a list only has the order of the items to relate between them. But if you have something like the name of an item and you wanted to correlate it with the price of an item, then dictionaries provide a much better way to associate those two separate pieces of data. So to understand how that works, let's take a closer look at dictionaries. Dictionaries are similar to lists in that they let us store data and we can access it using these square brackets. But instead of an ordinal index, and here ordinal means integers that are in a sequence, a dictionary uses a key, which could be anything, a string, a number, or even more complex things like a tuple, which you're going to learn about in the next chapter. And in this example, I'm using a string as a key. So if we know the key, we can look up the value of that item instantly without having to go through every other entry in the list. So for example, in this dictionary, if I know that I want to look up the price of apple and I can provide that key as a string, then that lookup is instantaneous, whether I have 10, 20, or 10 million items in the dictionary. Here's a very basic code example of how to create a dictionary in Python. So we'll start by writing the variable name. Here I'm writing fruit prices. Instead of the square brackets like the list, you need to use these curly brackets instead. And for each entry in the dictionary, I want to specify the key, which you see on the left. So those are the strings like apple, banana, blueberry, and then there'll be the colon, and that maps to the value we want to store for that key. So here I'm saying that the apple is 99 cents, the banana is $2.50, and the blueberry is $3. And once we've created this dictionary, it's going to be stored in the fruit prices variable, and then we can access any of the values we want. To access the value in a dictionary, we can use the square brackets just like with the list, except that instead of passing an index, we pass in the key. So here in this case, my key was apple, so I can access the price of apple by typing food prices, and then open the square brackets, and then the string apple. This is useful if our data doesn't have any kind of explicit ordering in its relationship, so we don't care whether an apple or banana comes first, the order doesn't matter. But we do know something unique and specific about the item we want to access. So that's where a dictionary is useful. What about adding items to a dictionary? You can't use the append method like you can with a list, but there are two ways you can do this. The first way is to use the assignment operator directly like this. So if you type something like food prices and then you want to add a new key called watermelon, then you could literally just put that in as the key and then use the assignment operator to set that value. And when you print the dictionary again, you'll see that the value is there. The second way you can do that is using this built-in update method, add. And that does pretty much the same thing as the assignment operator, so it's just a matter of which one you prefer. Now, before we go further, let's open up our code editor and actually write some of this code out, just so that we can see how it works. So I'm creating my dictionary here using these curly brackets. I'm going to zoom in just so you can see that a little better. It's these ones there. And then here we can write the key for our item. So for example, something like apple, and we can set its value using the colon. And this doesn't have to be a number either. It could be integer or it could be another string. So yeah, the key and the value can be mostly any primitive data types that Python allows. I'm actually going to make this an emoji again, just because I think it's better for visual learning. And we'll keep this as a float price. And we do need the commas to separate each entries that we add. I'll do a banana, also do a blueberry. So there's my first dictionary, and I can print that out just so you can see how it shows up in the Python terminal. And then when I run that, you see the dictionary here has these 3 elements. Now let's try adding stuff to it. So I'm going to keep this print statement here just so that we see how it looks when we first create it. But now I'm going to add that watermelon. And then if I print it again, you'll see that the new dictionary now has this new entry in them. And if I do this and I overwrite it, maybe I'll use the banana here and I'll overwrite it with a different value, you'll see that the value is actually updated from when we first created it. So if we try to use the same key and we add a new value, it's basically going to overwrite any value that previously existed. Now let's also try updating a dictionary using the inbuilt update method. To update something in a dictionary, we actually have to pass in another dictionary. I can create another dictionary, or I can inline it, which means basically just create the dictionary within the scope. And I could do that just using the curly brackets again, which is the same thing here, except that I'm just creating it here and only using it here. So now if I run this, and let's say I make the price 5, and this is actually going to be a dictionary, just like this one. I run that, and now that works. So this update function will add whatever is in this input dictionary to this original dictionary. I can actually extract this into a separate variable. So let's call this x, just because it's not something significant at the moment. And we're just going to pass that in right here. But I'm going to also add additional values to this. I'm going to actually copy this banana one so that I want to change its value. So I'm going to change that to $1. And now when I run this, you could see that when I update it based on this dictionary, not only do I add the cherry, but I also update the value of the existing banana. So this syntax is very useful if you want to do multiple operations at once to the values in a dictionary. Otherwise, if you just want to add one thing at a time, you could just do it like this. And if you want to remove items from a dictionary, you can also use the pop method like you did with the list. So let's pop out the apple and then see what happens when we print the fruit prices. And then if you print it, you'll see that in the output dictionary, we no longer have the apple. Now let's clear this up because I want to show you something else. What if we try to access an item in the dictionary where the key doesn't exist? So now I'm trying to access the kiwi price, and I'm going to go to fruit prices and look up this key, which is the kiwi fruit. And if I run that, it's going to crash with a key error saying that it can't find this key inside the dictionary. That's because I haven't created it yet. Now, this is not a very nice experience because sometimes when you're writing a program, you don't know ahead of time whether or not the dictionary has this value. So if you try to access it and it's not there, your program will crash, and you never want your program to crash. You have 2 options for how to deal with this key error. So your first option is to use an if condition to check if this item actually exists in the dictionary. You could do it like this. If And then you could do the key of the item, so the kiwi fruit, and then you use the in keyword, then you put the name of the dictionary. So if the kiwi fruit is in the fruit prices, then this condition will enter, and then we can get the price, and we can print that out. And if this condition isn't true, if this fruit doesn't exist in the dictionary, then we can use an else statement and do something else. So we'll say that kiwi fruit not found. So now if I run this again, you'll see that it shows kiwi fruit not found because this expression evaluated to false. However, if I do add the kiwi to the dictionary and I run it again, then this condition will be true, and then this code scope will be entered, and we will see that the price of the kiwi is printed. Now, there's also another way you can deal with this problem. So imagine that we actually don't have the fruit here again. So instead of doing all of this, we can use the built-in get method with the key instead. And now, if I print this out, you'll see that it doesn't crash anymore, and the kiwi fruit doesn't exist, but this method will return none. When I print out the price, it says the price of kiwi fruit is none. It doesn't exist. But if we don't want that behavior, if we don't want the default value of something to be none, we can actually specify a default value as the second argument of this function. So let's say that I'm designing a database for price lookups, and if I don't find the price of something, I'm going to assume that the price is 0, for example. I don't think that's a good store policy, but for the sake of this example, let's just try that out. And then when I run it, you could see that instead of none, the price is now set to 0 because I specified that as the default there. And I can change that to whatever number or whatever value I want, and it's going to reflect when I try to get that item. So that covers some of the basic things we can do with dictionaries. Now let's take a look at what else you can do with them. Python actually offers a bunch of helpful built-in methods that you can use with dictionaries in addition to what you just saw earlier. For instance, just like with list, you can use the len function with a dictionary to tell you the length of the dictionary, which will tell you how many items are inside that dictionary. So if I use that on this fruit prices here, and then I run that, that's going to give me the number 3. Dictionaries also have their own inbuilt methods, which you can use to manipulate the data that they contain. So you can clear a dictionary, or you can get an item, you can pop an item, and you can update the dictionary with another dictionary, as we saw in our example from earlier. You can use this inbuilt keys method to return a list of all the keys in the dictionary. But if you're interested in the values of the items in the dictionary, you can use this values method instead, and this will give you the value you store for each key in the dictionary. And if you need both the key and the value that they are storing, you could use this items method, and it will give you a list of pairs of data that will be the key and the value. This is useful for if you want to iterate through all the items of a dictionary, which actually brings us to our next topic. So even though dictionaries don't have an explicit ordering like a list does, you can still actually loop through a dictionary. And you can do this by using a for loop, just like you did with the list. But keep in mind that since dictionaries don't have an explicit order, this loop might not run in the same order that the items were inserted in. That's because dictionaries are an unordered data structure, which means there's no concept of a first item or a last item in the collection. So let's go to our editor and see that in action. So I'm going to write the loop like this: for key in fruit prices. And then I'm just going to print the key. And if I run that, you see that I actually just get the keys of the items inside my dictionary. I don't get the values. So if I want the values at each step, I actually have to use the key to access it. So I'm going to add another print statement, and this time I'm going to pass the fruit prices with the key. So if I run that again, well, now this is what my output looks like. I have the key printed out first, and then I access the value by using the key. When you write a loop like this for a dictionary, this value, this variable here in the loop, is just going to be the key. But if you want both the value and the key at the same time when you loop, you can use the inbuilt items method that we saw earlier. So that's where it becomes useful. And now, instead of just having the key, we actually get another variable we can use in the loop, which is the price. So instead of doing this, we can print out the price directly. And then if I run that, you'll see that it does exactly the same thing. But this just looks a little bit easier to read. The data inside a dictionary doesn't all have to be the same type either. Another way to use dictionaries is to store different pieces of data about a single object. Let's look at this example here, where I have an object, a variable called shoe, and in that variable, which is a dictionary, I'm actually storing all types of information about it. I'm storing a name, which is a string, so this one is Nike Air Max 2020, and I'm storing a color as well. Actually, I'm storing a list of colors, and it has red, white, and black. And I'm also storing the price, which is a number. So here, I'm not storing something like a collection of different items, but I'm storing a collection of data, different data, about one item. This is a really useful way to group data that belongs together for some kind of logical reason, and it makes things easier to access and associate when you want to model real-world objects in your application. For example, this Nike shoe piece of data that I'm storing as a dictionary here would be really useful if I wanted to build an e-commerce online store. Let's pop over to our editor and see why this is useful. Obviously, if I have my shoe item as a dictionary here and then I print it, I get all of this information out. But for example, if I just wanted to see what the price of the shoe was, I can access that specific item. So I can type in shoe and then price. And then when I clear my terminal and I run that again, I'll see that I get just the price of the shoe. And this way, I can actually access different pieces of information about my object however I want, just using this dictionary. So I can get the name and the price, and I can even get the colors if I want. It turns out that most of the data being sent back and forth from the internet, from websites and applications, can actually be represented as dictionaries, just like this one. The problem, though, is that dictionaries are a Python concept, and they don't exist in other languages. How do we communicate data to other systems that don't use Python? We can do that by turning it into a format that everybody understands universally. And the process of translating something that's kind of domain-specific to a general format, that process is called serialization. Python dictionaries can actually serialize very nicely into something called the JSON format. And JSON stands for JavaScript Object Notation. Here's what a shoe object would look like as a JSON format. As you can see, it's practically identical to the Python dictionary format, which is a really nice bonus because it makes working with this data a lot more intuitive when you're using Python. And JSON data is practically everywhere. It's pretty much how a large part of the world communicates with each other via the internet. Python actually has a really easy way for us to convert to and from JSON data. So let's go back to our editor and see how that works. First, we're going to have to do something we haven't done before, and that is to import a library. And this basically just pulls in a bunch of code that we can use that we don't have by default if we don't import it. And now, using this JSON library which is imported, we can type json.dump_s, which means dump to string, and we'll pass in our shoe object of the dictionary here. And this will return a JSON string, a JSON representation of this Python object. And if I print the result, you're going to see that it actually looks very similar to our actual dictionary. It's pretty much the same thing, but if you actually look at the type of this object, so in Python we can do that by using this type function. If I run that, you actually see that that's not a dictionary, it's actually a string. So this has turned into a string which we can send over the internet or send through a connection, and other apps will be able to deserialize this into the native representation that they like to use. Now, we're not going to be using this JSON stuff anymore for the rest of the tutorial, so you don't have to worry about remembering this just yet, but this will come in handy if you ever have to write Python code that has to communicate with the internet. As usual, let's finish off with a short coding exercise. For this exercise, I want you to imagine that you are making an online expense tracking app, so like a personal budget tracker. You're using a dictionary to store the total expenses for the things you buy. So this isn't a list of expenses, this is like a total amount for each category. Here, we're going to start the dictionary off with a couple of fields already. So we've got a total expense for food at $40, transport at 0, and shopping at 109. And what I want you to do are two things, so you can see them in the to-do comments there. First of all, I want you to add a new expense, a new item to the dictionary, and that's going to be an entertainment expense of $20. you'll have to figure out how to add a new key and new value to the dictionary. You also want to spend an additional $12 on food and update that to the dictionary as well. So by the end of this, food should be 52 because you're adding 12 to the existing 40 value. Write this code out, pause the video, and just give this exercise a go. And when you're ready, hit resume to see the solution. So here's my solution for this exercise. And there's a couple of different ways you can do this. I'm using the key directly in the dictionary to assign a new value, 20, to the entertainment expense. And this will add it because this key doesn't exist yet. Alternatively, you can use this update method as well. Or if you want to make this consistent with the way that you update items, you don't know whether or not entertainment already exists in this dictionary, you could do it in a safer way by setting it equal to the existing value of entertainment, or 0, which is the default, and then add 20 to that. So this would be a more robust way to do it, even though we don't need it for now because we don't actually have an entertainment expense. Now for the food expense, we are actually adding a value, and we can actually use the increment equals operator here, so plus equals 12. So this will take the existing value of food, 40, and then add 12 to that and update that. But again, we could also do it this way where we get the value of food if it exists and then add it and set the default to 0 if it doesn't exist, just to make sure that we don't hit an error if that item isn't there. And by the end, we can print the total expense to see if it's correct. So my output now has that entertainment at 20 and the food at 52, which looks correct to me. So now I hope you feel comfortable using dictionaries in Python. It's an extremely useful data structure, and you'll definitely be using it a lot going forward. See you in the next video, where we'll learn about 2 other extremely useful data structures, sets and tuples.